Alright, so this is our first set of notes. Unit 4. Unit 4 is called Congruent Triangles. This unit is going to be all about triangles. It's a good switch from what we just did because it's not graph heavy. There are some graphs in this unit. I mean, you're going to be dealing with graphs for the rest of geometry, to be honest with you. We try to connect everything to a graph at some point, but it's not as graph heavy. We bring a lot of algebra back in this unit, I can tell you that too. Which is why it's good to do those warm-up problems, just to make sure y'all tight on your algebra. So the first set of notes is called classifying triangles. Like I said, a lot of this is going to feel familiar. It's only some new stuff I'm going to show you at the end. But most of this y'all should already know from previous knowledge. So at the top, two ways we can classify triangles. The first way up here at the top is by their angles. So based on the angles of a triangle, we can classify a triangle. If a triangle has three acute angles, acute meaning what? Anybody know what acute means? Yeah. So all the angles would be less than 90 degrees. And that's all three angles. You have an acute triangle. Acute. Obtuse triangle. If just one of your angles is greater than 90 degrees, one angle greater than 90, then the triangle is an obtuse triangle. Obviously, we all should know what a right triangle is. Right triangle, one angle equals 90 degrees. Right triangle. And our last one is when you have three congruent angles. You see these congruent symbols, y'all should all remember this. These congruency symbols in the triangle. If that's the case, all three angles are congruent. We will call the triangle equal angular. Don't try to spell ahead of me, y'all don't know how to spell it. It's equal angular, it's not equal. Let me say it right. Equal angular. All one word. Alright, so the four ways we can classify triangles by their angles. Based on that, let's answer these questions down here. Using the diagram, classify each triangle by its angles. So in this diagram down here, let me zoom out a little bit. Just a little bit. Diagram down here, you got a whole bunch of triangles connected here. And then you got triangles. You got one big triangle, then you got a bunch of little triangles inside. And based on the way they name the triangle, that's what triangle they want you to look at. Y'all should still be able to figure this out based on the way we name a triangle. The first one, triangle CDE. Look at your diagram. Find triangle CDE. Based on the way they named it, look and find that triangle in the diagram. Devin, start us out. We want to classify triangles CDE by its angles. Make me proud, Devin. We're recording, Devin. We're going to come back to you. Savion, go ahead. It's a right triangle. Number one is a right triangle. I'm just asking, man, you having trouble seeing that? Are you okay? Can you hear me? You having trouble seeing that? Are you okay? Number 2, triangle BCE. BCE. Tally. Say it one time louder. Yeah, obtuse triangle. Jorge, triangle ABE. Say it one more. Yeah, that's not the way we name it though. Yeah, okay. What's the name I gave you? Equilateral. Triangle. Triangle BDE. Excuse me. Billy, finish this off. Yes, obtuse. Alright, so that's by its, classifying by its angles, and you need to be able to classify a triangle by its sides. These should be familiar to y'all. So if a triangle has 3 congruent sides, y'all should remember what we call this. Anybody know far right? No. It's by classifying by its side. Acute means angles. I agree that these are all acute angles, but you classify them by its size now. These are all words y'all should already be familiar with. I'll say it for you. Who said it? What now? Yeah, equilateral. What's the equilateral triangle? Let me ask you this, and you should know, what's her name, Jalen? If the triangle is equilateral, it's also what, Jalen? Stuff at the top. Say it louder. Yeah, if the triangle is equilateral, it also has to be equiangular. If all the sides are going to be the same, all the angles are going to be the same as well. Those two go hand in hand. 2 congruent sides. Anybody remember this word? No. Y'all don't have good memories. Isosceles. I know y'all got taught this before. Triangle has 2 congruent sides. It's called an isosceles triangle. I'm gonna show you this again at some point, but I don't like teaching ahead too. The triangle has 2 congruent sides like this. The angles opposite of those sides, here and here, would be congruent as well. But that's just visual too. You should be able to see that. Isosceles triangles always have 2 congruent angles, as well as 2 congruent sides. If a triangle has no congruent sides, we call it scalene. if they were to mark this triangle, they would mark it with all different markings. They would mark this like this, this one like this one like this, indicating to you that none of those sides are congruent to each other. So now, using the diagram, classify each triangle by its sides. So using this diagram over here, on this diagram too, they mark sides for you too. They mark these sides all with the same marking. They mark these sides with different markings for a reason, telling you that these two sides are congruent to each other, but they're not congruent to these sides over here. Alright, first one is triangle JKM. Victoria, triangle JKM, classified by its sides. It is scaling. JKM would be a scaling triangle. Triangle KLN. Eric. Isosceles. And then triangle JKN, Miss Welch. Miss Welch, triangle JKN. Equilateral. Alright, that's all individual. Yeah, that's easy. What we're going to ask you to do is classify triangles by their angle and their sides at the same time. So, let's do that. Rama, number 8. Classify this triangle by its angles and its sides. Angles first. Yeah. So, by its angles is what kind of triangle? This ain't no trick. What kind of triangle is it? Oh, Jesus. I'm going to come back to you. Tylee, go ahead. By its angles, man. Pay attention. Oh, my God, Jesus. We're going to come back to all y'all. Jasavion, just help me out, bro. It's a right. And then by its sides. What else is it? It's right and isosceles. Oh my God. It ain't the same thing. Well, I don't call it 90. What you think I gave you all those words for? For you to call it something else? Other thing, teaching moment for y'all. This is why I talk about y'all have to start using common sense. Anybody know what a triangle adds up to? 180? Alright. So, this triangle is a 90-degree triangle. I mean, a right. Look, he got me calling it a 90. See? That's a problem. It don't even sound right. A 90-degree triangle. We call them right triangles. This is a right triangle. This angle is 90 degrees. Since Jasavion said this is isosceles, I know and I can see they mark these two sides congruent, but I know these two angles right here are congruent as well. My question to you, if these two angles are congruent and this angle up here is 90. What would the value of these two angles be? Let's see. Oh, y'all already know. Good. 45 degrees. This would be a 45-degree angle. This would be a 45-degree angle. This is actually a special right triangle. We call it a 45, 45, 90. But yeah. If the triangle's going to be right in isosceles, it's going to be a 45, 45, 90 like this. Alright. I'm worried about something, y'all. Number 9. I don't even know who to call no more. Y'all throwing me out under the bus. Go ahead, Victoria. Obtuse and what? Okay. Well, on this one, you don't know. You can't assume scaling. But luckily, we know math, so we can do math. No, I don't disagree with you. That's true. This is obtuse and scaling. If it was isosceles, they would have marked them. I'm assuming. And I made that mistake. I'm sorry about that. I agree. It looks that way, but the degrees could be off just by a little bit. One degrees could be 33, the other one could be 35. I mean, no, not 33. 32, the other one could be 34. You would think that, but how do you know?
I just did the math.
I know, but I'm saying, how do you know? What did they tell you to tell you that those angles were congruent? You're assuming. I did too, and I'm thinking about it. I taught my kids wrong last year too. I'm looking at my old notes. I shouldn't have done that. I sat there and put markings in myself when I shouldn't have done that. You can't mark a figure if it ain't marked already. If this isosceles, they'll start out by telling, they'll at least indicate to you that some sides are congruent. If they don't do that, don't assume that. That was my bad to assume that, and I got y'all assuming too, and I ain't even taught y'all to assume yet. Don't ever assume. We'll give you enough information for you to be able to figure out if something's isosceles or if it's scaling or whatever. Like literally, I know y'all both y'all calculated them as 33, and I'm glad y'all can figure that out. But what if this angle was 32 degrees and this one was 34? They so close, how would you know? Just by looking. You see what I'm saying? You can't assume. Don't assume. So in this case, the best scenario to go with is scaling. This side could be a little bit shorter than this side. Could be. May not be. But they didn't give us enough information to assume anything else. Good job, Victoria. On this one, they give you enough information to assume things. No, Tyler. Go ahead, Tyler, then. Thank you. Equal, angular, and equilateral. So that's classifying triangles. You're going to be asked to do that. It's not a hard thing for y'all to do. Taking it a step further, though, being able to classify a triangle on a graph. That's what we teach you on the back. You may not like it, but we're going to do it. And we will ask you to do this. We're going to mix this with some skills that we already know. I'm going to see if I can jolt your memory without having to tell you everything to do. Alright. So in the back, classifying triangles in a coordinate plane. It says, find the distance of each side and classify each triangle by its size. Keep in simplest radical form if necessary. There go that statement in here. Simplest radical form. Going back to that. That's a skill we already know how to do now, though. So I'm putting this figure on the graph. A, B, C. -7, -7. -9, up 1, and then -1, -1. Oh, label A, B, C. Don't worry, we're not rotating or nothing like that. We're good. We're done with that. Well, we are. Isaiah's still rotating because he's taking the test. So this figure is on my coordinate plane. They want to know, and it's a triangle. They want to classify it though. They want us to classify it as isosceles, equilateral, or what's the other one? Scalene. Looking at this one, to me it looks like it could be a couple things. It looks like it could be equilateral, or it could be isosceles. I don't even know. If I check all my measurements, it could be scalene. You have to actually go and find the length of the sides. But y'all should know how to do that. Y'all should still remember how to find the length of the side, something when it's on a graph. What do we have to do? Somebody spit it out. Don't be scared. I told you we're going to be using it the whole year. There it is. Emma, say it again for him. Pythagorean Theorem. That's where we at. Alright, so we're going to do Pythagorean. Before we do Pythagorean, though, let's go and get make all our triangles and get all our sides. I'm doing that for a reason. I'm going to show you something. Show you a way to save time for yourself. So, you know you got to, and let me label out here what all sides we got to find. I'm going to do it out here first. So we got to find the side length of AB. Then we got to find the side length of BC. And then we need to find the side length of, what is it, CA. So we got to find those three side lengths using Pythagorean. AB first. I'm going to make my right triangle on the outside. You zoom in for y'all. I'm counting my horizontal and my vertical. Horizontal is 2. Vertical is 1, 2, 3, 4, 5, 6, 7, 8. Thank you. So that's for that one. I should have color coded my stuff I was supposed to find. I'm gonna color code these. Next one is BC. Making a triangle outside of BC, right triangle. Horizontal is what? Somebody counted that already? 8. Vertical is 2. Then my last one, CA. Horizontal is 1, 2, 3, 4, 5, what? 6. Oh, don't yell at me. And vertical is 6, 2. Good. I'm glad y'all can move faster than me. Good. Reason I go through and make all my triangles first, because to help me save myself time, I like to see if any of my triangles are the same. Are any of my triangles the same? The one for which 2 segments? A, B, and BC. So when I do Pythagorean Theorem, what I tell you is going to give me for those two? The same answer, right? So the reason I do that, because some kids will sit there and work all these out like, wow. You at least right now, by this point, you know this triangle is at least what? What could be classified as what? Isosceles, right? You know at least 2 of the sides are the same. You're just not sure about this third side. So you really got to check for the third side right here and see if that's the same. Because just because these numbers are different don't mean you won't get the same exact number. Sometimes it does happen like that. Alright. So I'm going to solve AB just to have a number for it. So I'm doing 2 squared plus 8 squared equals C squared. Oh, my bad. Didn't know I wasn't showing y'all that. And y'all should know why I'm doing that. Y'all should still remember this. 4 plus 16, that ain't 16, 64. I was testing y'all again. Equals C squared. But 68 equals C squared. And then we take square root if y'all remember. Now they told us to leave these in simplest radical form. Huh? Oh, okay. I need somebody to break that down for us. Can that one be broken down? See if 4 go into 68.
Goes into 64 17 times.
Say it again.
Goes in 17 times.
It goes in 17 times, so split 4 and 17 under that.
I wasn't waving it, I was waving you off. I was stretching, yeah. You got a pump? Say no, try to square it.
Hey man, don't make me. I hope you ain't saying nothing inappropriate.
I said they say me on trying to square up with everybody.
I'm recording. Okay.
I didn't say nothing.
So I said the breakdown was 4 and 17. So under the radical, we're gonna have square root of 4, square root of 17. What's the square root of 4? 2. So we can bring that out. So it'll be 2 square root 17, right? Equals C. I'm sorry, I'm like running out of space right there, y'all. But hopefully my new people, y'all teacher taught y'all how to simplify radicals. So this one is 2 square root 17. That means BC is what? Yeah, 2 square root 17. So BC equals that to 2 square root 17. We just got to find CA. Should have moved CA down a little further. Matter of fact, I'm going to scratch that out and move it down further and do it in the color I got it on the graph. CA down here. CA was 6 and 6, so 6 squared plus 6 squared equals C squared. 36 plus 36 equals C squared. What's 36 plus 36? 72. Well, right there, that'll tell you. Since we didn't get 68 under the radical, that'll tell you that that side is different. But we can simplify, I might as well. Under the radical sign, we can do 9 and 8. Square root of 9 times square root of 8. And then we could take the square root of 9. That's going to give us 3, right? The 8 we need to break down a little bit further. Square root of 4 and square root of 2. My bad. I wasn't showing y'all that. Sorry. Then we can take the square root of 4. That'll be a 2, 2. So let me scratch that out. Let me do my double 3s and then my double 2s like y'all used to. Circle, circle, doubles, my doubles. Both of those coming out. So my answer for this one, CA would be, on the outside is 3 times 2, so y'all should know that's 6 square root 2. For those who don't know, once again, I don't know how y'all teacher taught y'all, the kids who come to me new. I taught them every time they see doubles, they pull them out. So we're pulling out a 3 and a 2, and we're multiplying those together on the outside. I don't know if I need to show y'all that, but hopefully I don't. If y'all want a simplifying radical sheet, y'all can get one from me. I got some still printed. You can practice. My new folks. But that has already been taught. So all in all, these two are the same. This one's different. They want me to classify this triangle. I will classify this triangle as isosceles. But you just have to check first. You obviously know I'm going to leave number 12 to you. Thank you, sir. I'm leaving number 12 to you. I'll come around and see if you did it right. Classify it.